In this video, we'll take a look at GPs, or geometric progressions. So in a GP, the first term is always given as A and the common ratio as R. So the common ratio, to check for the common ratio, we will divide a subsequent term by the term before. So un plus 1 divided by un. Or, for example, the second term u2 divided by the first term a equals r, and that should always equal u3 divided by u2, and so on. In a GP, the nth term is given by un equals a times r raised to the power of n minus 1. And the sum of n terms is given as Sn equals a on 1 minus r to the power of n, all divided by 1 minus r. So we're going to look at some examples now. And the first example A, we just find an expression for the nth term of the GP, 3 plus 12 plus 48, and so on. So in this GP 3, 12, 48, we're going to find an expression for the nth term. So we know the formula for the nth term is un equals a times r to the power of n minus 1. So we can actually just plug in this case, a equals 3, and r is 12 divided by 3 is 4. And just to check r, we've got 48 divided by 12, that also equals 4. So we'd simply say un equals 3 times 4 raised to the power of n minus 1. And that's good enough to give us an expression which will help us calculate any term when we have a known value of n. Example B, find the 25th term of the GP, 5 plus 10 plus 20. So in this GP, the value of A equals 5, and the value of R is 10 divided by 5, which is 2, and that's the same as 20 divided by 10, so it is a GP. So we're looking to find the 25th term, so U25 equals A, which is 5, times R raised to the power of 25 minus 1, so 2 raised to the power of 24. If we want to calculate that out, that is a very large number. On the calculator would be 83886080. So that's the 25th term of the GP. Example C, find the sum of the first 10 terms of the GP, 5 plus 15 plus 45, and so on. So 5 plus 15 plus 45 is a GP with A equals 5, the first term. 15 divided by 5 is 3, which is R. 45 divided by 15 is also 3, so R equals 3. We're asked to find S10. So we have the formula for the sum of 10 terms is A on 1 minus R to the power of 10 divided by 1 minus R. So we plug them in to find S10. S10 equals 5 times 1 minus 3 raised to the power of 10, all divided by 1 minus 3. And we'll be careful to use brackets on our calculator and calculate it carefully to give us S10 equals 147,620. So S10. In the final example D, we're told that the first term of a GP is 8, and its common ratio is given by R. So we're given that S3, the sum of the first 3 terms, equals 38. We're asked to find 2 possible values for R. So in finding 2 possible values for R, we could use the fact that S3 equals A plus A times R plus A times R squared. And we're told that equals 38. 8. And what we have here is we know the value of a equals 8. We have a quadratic equation in R. So if we rewrite that, so we'll have 8 plus 8 times R plus 8 times R squared equals 38. So we can rearrange this so it's in the form of a quadratic equation where we set it equal to 0, and we'll be able to solve then. So we'll just have 8R squared plus 8 times R. Now if I bring the 38 over to the left, and I will have 8 minus 38, so that will give me negative 30 equals 0. And I can divide across by, in fact I can divide across by 2. The whole equation across by 2 will give me 4R squared plus 4R minus 30 equals 0. We could solve this quadratic equation using the quadratic formula, minus b plus or minus square root of b squared minus 4ac all over 2a. Or if we can't factor it, then factoring would be quicker to solve the equation. So the two linear factors, we can have 2r minus 3 and 2r plus 5. So those two linear factors will give us our solutions. So the solutions, when we have linear factor 2r minus 3 equals 0, well then one possible solution for r equals positive 3 divided by 2, and the second factor 2r plus 5 equals 0. The other solution would be r equals negative 5 over 2. So those are our two possible solutions for r. And that's all for this video. Thank you for watching.